Okay, so yesterday you did hypothesis testing with p-values. Today we're going to do hypothesis testing, so same sort of method that you did yesterday, but with rejection regions. Rejection regions are the more common way to do hypothesis testing. So when you get to the test, more than likely you're going to use rejection regions instead of the p-value because you're going to see, I think it's a little easier. Okay, so a rejection region is that shaded region on the normal curve. If it's the left tail, it's on the left side. If it's a right tail test, it's on the right side. If it's a two-tail test, it's on both sides. We use a rejection region to determine if we reject the null hypothesis or do not reject the null hypothesis. So at the bottom here, we're going to start by figuring out what the critical values are. The critical values are at the end of the rejection region. It's where the shading starts or stops at. Once we know the critical value, we can shade, and then we can find our scores and determine if they're in that rejection region or not. Okay, so we're going to start by doing that. If you guys don't have out your standard normal, your Z tables, grab those real quick, because we're actually going to add a couple of things to the top of them. And when you get them, you can see this is like the paper you'll get on the test. These are going to be written in for you, some of the common critical values that we use. Okay, so find your standard normal distribution table, and on one of the two sides, I don't care which one, you need to write in these values. Okay, so alpha is our level of significance, and we have three that were common, the 0.1, the 0.05, and the 0.01. And then next to that, it tells you what the critical values are if you have a left tail, a right tail, or a two-tail test. So most often, we're going to be using these, and you're just going to be able to find them straight on the chart. Again, on test day, you will be given these values. All right, so I'm going to pause this for a second. I'm going to give you just a couple minutes. Write them on your table. And then we'll come back and we'll talk about how you find one if it's not on the table. Bless you. A hypothesis test where it was a level of significance of 0.05 and you figured out it was a left tail test based on your hypothesis, you would use the critical value of negative 1.645. Okay. All right, so let's say it's not a 0.1 or a 0.05 or a 0.01 and you have to find the critical value yourself. So you're going to need to hunt for some things on your chart. If it's a left tail test, I'm going to draw a picture of that. What you're looking for is the Z value, that's our critical value, that will give you an area of 0.03 to the left. So that situation, we've done this before, that's what's on your chart is area to the left. So you're just going to find 0.03 in the middle somewhere, and you're going to find the Z-score that's closest to that. So that's going to be on the negatives, of course. It's on the left side of my curve there. It's a negative 1.88 would be the critical value. Usually we'll do like a Z sub C for critical value, something like that. Okay, everybody see that okay on their chart? So that the Z score of negative 1.88 has an area in the middle of the chart at about 0.03. It's like 0.0301. That's the closest you can get to it. Okay, so you're hunting for the area and then working backwards and finding the Z-score associated with it. Okay, if you have a two-tail test, that means the 0.08, that level of significance, is divided in half. So you've got 4% of your area on the left and 4% of the area on the right. That 0.04 is, again, area to the left of a certain critical value, so that's what you're going to hunt for in your chart. And then in this case, when you have a two-tail test, you're going to have plus and minus critical values, one positive, one negative. But the 0.04 is what you can search for. So the closest I can get to 0.04 in the middle of my chart is a 0.0401, which is a Z-score of negative 1.75. So my critical values are negative 1.75 and positive 1.75. So plus and minus 1.75 would be the critical values you would use for that hypothesis test. Okay. Make sense? Okay, but again, 99% of the time, the ones that you're going to need are going to be at the top of your table. All set up for you. Okay. So decision rule based on rejection regions. pretty much, if you calculate a z-score and it is in the rejection region, you reject. That's why it's called the rejection region. And if it's not in the rejection region, you do not reject. Everything else we're going to do today is exactly what you did yesterday as far as the steps for hypothesis testing. Okay, the first thing we're going to do is just practice. At the bottom here, you can see we've got a two-tailed test, and they're already telling us what the critical values are. The critical values are plus and minus 1.96. So let's say you're doing a hypothesis test, and based on your data, you get a z-score of 1.98. Okay, is 1.98 in either of those shaded regions at the bottom?
No. Wait, yes.
Yes or no?
Yes.
Yes. So because 1.98 right there is in the rejection region, that z-score would tell us to reject the null hypothesis. Okay? What about negative 1.89? Right, so negative 1.89 would be close to it, but like over there somewhere. Okay, so we would fail to reject or not reject. You could word that either way. 1.65, reject or not reject? Where's 1.65? Is it in the shaded region? It is not. So if it's not in the shaded region, we do not reject. And then negative 1.99. Over there somewhere on the left. So we would reject it. Okay, so I like this better because you don't have to remember with like the P and the alpha, what you do when it's greater than and what you do when it's less than. It's very clear when you draw the picture. If it's in the shaded region, reject. If it's not in the shaded region, you don't reject. So this is the one we'll use more often. All right, so let's actually do a hypothesis test now. So it says employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of its competitors, which is $88,200. A random sample of 20 people at the company's mechanical engineers has a mean salary of $85,900. Assume the population standard deviation is 9,500 and the population is normally distributed. At a level of significance of 0.05, test the employee's claim. Okay, so before I go anywhere else, I need to first look at, is my population normally distributed or is my sample size bigger than 30? Okay, it's normally distributed. Check. The next thing I want to look at is my standard deviation, because for right now it really doesn't make a difference, but when we get into the next section it is going to make a difference. If you know the population standard deviation, which we do here, that's going to tell us we're going to be using the z-test. But remember when we did our confidence intervals before, when we didn't know the population standard deviation, that was a t-test. So in the next section, you're going to have to distinguish between the two. When do we use the z method and when do we use the t? So that's a z. All right, so things that I know. Population standard deviation is 9,500. I have a mean salary of 20 people. So my sample size is 20. And from that sample, we get a mean. So X bar is our sample mean, 85,900. We have a level of significance of 0.05. And then 88,200 is going to show up in our hypothesis we're going to write in a second. That's a value of the population mean that we're testing. Okay. So next thing we want to do is write our null hypothesis, our alternative hypothesis, and label which is the claim. Okay. So again, the claim that's being made is that the mean of the mechanical engineer's salary is less than that of its competitors, which is 88,200. So if we see the word less than, or the words less than, is that going to be in the null or the alternative hypothesis? It's going to be in the alternative. So that the mean is less than 88,200, and that is the claim. So if that's the claim, what's the null? What's the complement of that? greater than or equal to 88,200. Once you have that, you can figure out if it's a left tail, right tail, or two-tail test. What kind of test is this? Left tail, right tail, or two-tail? Right, so we look at this alternative hypothesis. It's less than, so that tells me it is a left tail test. Okay, and now we can put two pieces of information together. We know it's a left tail test, and we know our level of significance is a 0.05. Find the critical value. So this is one of the ones, if it's a 0.05, it's a common level of significance. It's one of the ones you guys wrote in. So find left tail 0.05, and we're going to get a critical value of z of negative 1.645. Okay, and you can even draw the picture now if you want to. I would encourage you to do so. There's my rejection region. Okay. The last thing to do is to calculate our z-score that comes from our sample information and determine, is that z-score going to be located in this rejection region or not. The formula that we use for this always was x bar minus mu over the standard deviation divided by the square root of the sample size. Okay, so we're just plugging it in. We get 85,900 minus 88,200 over 9,500 divided by the square root of 20. I'm just going to type all that in the calculator. So on top, I get negative 2,300. On the bottom, I get 2124.26. And if I divide them, which you might be able to do all at once, you're going to get a z-score of about negative 1.08. Okay. All right, so compare that to our rejection region. Is negative 1.08 in our shaded region? It is not. Okay, so it's going to be over there somewhere. So do we reject or not reject? Fail to reject. All right, once you decide if you're going to fail to reject or reject, then you're going to summarize. Okay, so if we fail to reject, do we say there is or is not enough evidence? How do we start this statement? There is or is not. Which one? Remember, rejecting is a good thing. So there is not. If we did not reject, that means we don't have enough evidence to really make a decision on the matter. Okay, there is not enough evidence. And then it comes back to what the claim was. The claim here was the alternative hypothesis. So do we use the word reject or support? Support the company's claim. Okay, so we don't have enough evidence to support their claim, so we're essentially shutting down what they're saying.
So anytime we use the alternative, we say support?
Yes, so use this if the claim is the alternative, and you're going to use the word reject if the claim is the null. Okay, and if you reject, there is enough evidence. If you do not reject, there is not enough evidence. There's a little grid 7.1 where we kind of talked about that. Okay. Questions on this process here? All right. Let's try another one. A researcher claims that the mean annual cost of raising a child, age 2 and under, by married couple families in the U.S. is $14,050. In a random sample of married couple families in the U.S., the mean annual cost of raising a child, age 2 and under, was $13,795. Bless you. Sample consists of 500 children. Assume the population standard deviation is $2,875 at a level of significance of 0.1 Is there enough evidence to reject the claim? Okay, so number one, is my population normally distributed, or is my sample size bigger than 30? Sample size is bigger than 30. In fact, the sample size here is really big, which is good. We've got a sample size of 500. Okay, what else do we know? Next thing I check for is my standard deviation. I have the population standard deviation, so that's going to allow me to use my Z's in a minute, so 2875. Let's see, the sample mean was 13,795. The level of significance was 0.10, and then the population mean, that's going to be part of our hypothesis that's being tested as part of the claim, is the 14,050. All right, so the claim is that the mean cost of raising a child in the U.S. is $14,050. So is that going to be, do you think, the null or the alternative?
The null.
It's going to be the null. So it's saying the mean is. So this is going to be an equal to, not equal to situation. The claim is that it is equal to 14,050. Label it the claim. So the alternative is that the mean is not equal to 14,050. Okay. Can you tell me if it's going to be a left tail, right tail, or two-tail test? It's going to be a two-tail test. All right. If it's two-tail, put that together with your level of significance to find your critical value of Z, and then we can draw our rejection region. So 0.1 and two-tail, plus and minus 1.645, and I would encourage you to sketch that. Okay, so we're going to have two shaded regions, negative 1.645 and positive 1.645. Okay. All right, calculate our Z-score. We're going to figure out if it's in that rejection region or not. So that's our sample mean minus the population mean that's being tested, 14,050, divided by my standard deviation of the population over the square root of my sample size. And then Z-scores, we usually just round to 2 decimal places. That's what our chart goes to. If you have a graphing calculator, you can use that alpha y equals to set it up. Makes it nice. That's going to give me negative 1.98. Type that in. So now we compare that to the rejection region. Is that in either of my rejection regions? Yes. So do we reject or not reject? If it's in the rejection region, we reject the null hypothesis. Okay, so that's our decision. All right, so now let's summarize that. If we reject, is there or is there not enough evidence? There is enough evidence, and because the claim is the null, we say to reject the researcher's claim. Okay. Makes sense? Any questions on any piece of this? All right. So last one of the day is for you guys to try, and I'm going to have everybody put something up on the board with this. It'll be a collaborative effort. As soon as we have it all up there, we're done. Okay? All right, go ahead and get started. I'll give you a few minutes. All right, let's see. Okay. I'm going to have you put up the sample mean and the population. I'm going to have you put up I have you put up the
put up the levels and then the left side.
You're gonna put up the critical value of Z. I want you to draw rejection. Okay. I want you to calculate Z, simple information. I want you to say we're gonna reject or not reject, and then you guys are summarizing. Whatever all this. Okay. Yes. So what's the claim being made? So is there enough evidence to support the claim that the highway miles? I think highway miles is the only thing that you're concerned about here.
Okay.
Yeah. Whatever, the city miles is like extra information.
Right to 49.
Yeah, make sure you guys are using the highway information. They give you some information about city, but the highway is what the claim is that they're talking about. Yeah, it's extra. Don't need it. On this. No? Getting the hang of it?
Yes.
Do you understand why we did this in little pieces leading up to this
Yes.
versus just trying to like do a hypothesis test all in one day? There's a lot of little things that go into it, so it was worth the extra time to practice it. Okay, so Math Excel, put that up there for you. If you can see it there, all three of the 7-2 sections, which go along with the 3 days we did the lesson, are due tomorrow night. Day 3 is a few of those, yes. But it's not like every problem is an entire hypothesis test. Like a couple of them will just say, based on the z-score, do you reject or not reject, that sort of thing. So there might only be like, I want to say like 2 or 3 at the most, hypothesis tests. Okay, so we're gonna do 7-3 tomorrow and Thursday. And then you won't have technically any homework over the weekend. It's a no homework weekend. And then 7-4, we've got 2 more sections. Then we're getting ready for your tests. We're getting ready for your third project. Then a couple more little things before our final. We're kind of rounding it out there. Do you remember what you need for your third project? the data that you need to collect.
Oh, you need my
Okay, you need 50 temperatures, 25 males, 25 females, about 2 weeks from now. That's what I'm telling you now. And you are not taking people's temperatures. All you're doing is putting a survey up or asking them to do it themselves and just reporting what their temperature is.
What if we had this little gun thing you just go?
Yeah, I have one of those in my house.
Actually,
I am not condoning that in any way.
It's ethical though.
I don't want to
I'll
know.
say.
Okay, the collection method is not very important here,
Okay, wait,
okay, but
so-
you need 25 male, 25 females, you have about 2 weeks to collect them, yes.
Can we look our research on, medical MP for the temperatures of males and females instead of the survey?
No, you may not.
That's so much harder now.
Sorry. All right, I'll do self-unlock.